Hi. This lesson, which is lesson 4 functions, is going to be broken up into 2 sections. So for this part, this will be for lesson 4A.
Hi. Before we go on to our next lesson, we're going to do a recap of lesson 7, which was interpreting graphs. So the first part you see vocab corner. We have word bank with all the words, and we're just basically filling in the blank. So for the first one, it says blank is the intersection of a horizontal axis and vertical axis. So think of the intersection of those two axes. You might think, okay, intersection of these two axes, which are those two lines, will give you a point. But where would you see all intersection of the horizontal axis and vertical axis? That would be coordinate system. So coordinate system is the intersection of horizontal axis and vertical axis. The next one is a representation showing each element of a domain and a range paired together. So we have elements. That's part of, that tells you what numbers will make either an equation or a situation true. An element of a domain and range paired together. So with those two put together, you would see that as an ordered pair. It's a pair that the two, domain and range, and it shows you the numbers that you see on the coordinate system. Next one, location on a graph represented by an ordered pair. So you know the ordered pair combines has x, y. So instead of x, y, you would have numbers, and it's located on the graph. That is called a point. So a point, go down, point is a location on a graph. So in order to say, okay, 5, 4 or negative 6, 4, that's a point, and it's written as an ordered pair. All right, the next one is the horizontal placement of a point. So the horizontal placement of a point. So on the coordinate system, or on a graph, the horizontal. What represents the horizontal placement? It's the x coordinate. Let me just get my thing. Okay. Try to get that x coordinate. Actually, I can scroll down. Come on, let's go. All right, x coordinate is the horizontal placement of a point. Next one, blank is a set of y coordinates in an ordered pair. So what represents the y coordinates in an ordered pair? Another name for y? Range. So I'm going to do this back and forth. So a range is a set of y coordinates in an ordered pair. Next one is a set of ordered pairs. So you don't have only one ordered pair, you could have 2, 3, 4, 5 all together. So when you have a set of ordered pairs, they are called a relation. Down, the relation is a set of ordered pairs. Next one is a set of x coordinates of an ordered pair. You already know that the range represents the y coordinate, so the x coordinates are also called domain. We got domain and range, the x and y. This. And the next one is the vertical placement of a point. You already did the horizontal placement of a point, which is the x coordinate. The vertical placement of a point is the y coordinate. You have the x, you have the y. And then for the last one, for our vocab corner, is a set of numbers or coordinates written in the form of x, y. So what is the last one written in XY? It's ordered pair. Ordered pairs are written as XY. Go down further. All right. So for this one, the second one, when we said about this is representation showing each element, a domain or range paired together, it's order pair, it's also mapping. Mapping is also another representation to show the connection, the relation between domain and range, as well as the order pair. Okay, so let's go on to the next one. Still continuing with interpreting graphs review. This one says put the following coordinates in a table and map it. So you're doing two things, a table and mapping. So for this one, we have the ordered pair. And if you were to do it as a map, you would have it in this form. Have the domain and the range. You put all your x coordinates under the domain. You put all your y points, your y coordinates in the range box, and then you just match up based on the order pair that is written. I forgot to put the table, but if you had a table, you would have the x and y. The same thing, your x column with all the x's, and then the y column with all the y coordinates, the y points, the y coordinates, and they're matching up, they're lining up. So the negative 6 would be with the -1, -5, -9. And then you also did a graph where you have to figure out what was independent, what's dependent. Remember, dependent is your x values and dependent are your y values. The y is dependent on the x. So it gives you an example. As a scuba diver's depth increases, the pressure on the diver increases. So identify the independent and the independent variables in a complete sentence. So which one represents what? So if the scuba diver is going down, he or she has to dive into the water, and the depth will increase. As further down this person goes, the depth is increasing, and the pressure is going to start increasing. Because imagine being all the way at the bottom of the water, the bottom of the sea, all that pressure of that water pushing on you. So in order for you to feel that pressure increase on you, it depends on how far down you go. So that means the pressure is dependent on the diver's depth. So in this case, the independent variable is the depth, and the dependent variable is the pressure. So the pressure is dependent on how deep the diver goes. And if you were to do this as a graph form, you would have your depth, which is the independent, which is the x values, and your pressure as your range, your y value, the dependent variable. And so each time the diver goes down, like let's say a foot, the pressure goes up, however much. All right. So before we go on to our next lesson, you see many pictures here. You see a vending machine, you see the ATM ticket machine, see a dog toy, and also a laptop. And the question is, what is common among these objects in order to make them operate? So if you look at it, try to figure out, okay, what do they have in common? So each of them, you notice that they have stuff that they have in common are buttons that you have to push. For the vending machine, you push some buttons, you have to put money in, push a button to get whatever snack you want. For this ticket machine, you need tickets, whether it's a Metro card or you're buying a Metro North card or a Long Island Railroad ticket, monthly ticket. You need to numbers or how many cards you need, the amount in order to get it. But this dog toy is a remote that allows you to press the buttons to make this dog walk and do whatever action you want it to do. And with the laptop, you have power buttons, you have buttons to press on the keyboard in order to either get to a game you want to play or email somebody or whatever it is. So what's common among these objects in order to make them operate deals with what we're going to be learning about in this lesson. So there's two words that we're going to encounter in the lesson: input and output. So in order to get something, you input by pressing the buttons or entering the amount of money that you need in order to get what you need, and then the output comes out the stuff that you want to get: snack, ticket, the dog doing a flip, or sending out your email to our friends. So our lesson for today is functions, and the objective is, how do we determine whether a relation is a function and find values of the function? So before we get further into function, we need to know what function is. A function is a relationship between input and output where there is exactly one output for each input. And a function is a relation in which each element of the domain is paired with exactly one element of the range. So you got an example with the domain, the mapping, how there's a domain for each range is one and only one domain. And same thing with the map, the graph. This is a function, and we'll find out why this is a function. And with your domains are the x values or your input, and the range is the y value, also known as the output. All right, so how do we identify functions? Basically, for every x, there's one y. So you cannot have multiple x's, repeated x's, in order for a function to be a function. So for this one, we have -2 going to -3, 0 to 6, 3 going to 6, and 4 going to 9. Is this a function? Yes, because for each x value, there is one specific y value attached to it. Now let's look at this. Domain is the x, the range is the y. If you look at the numbers for the domains, you notice that one is repeated. You can't have that happening. So 1 is for 4 and then 1 is for -4. There's only for each x, there is a specific y. So this is not a function. And what can be repeated in the relation? The range, the output, the y values. Y values can be repeated. Just like in this in this table, there's the 4s. If there was only one 1, this would be a function, even though you see the range that the 4 repeats, that would be fine. So what cannot be repeated in the relation? The domain, the input, the x value. You cannot have repeated x. If there's repeated x, then whatever it is, mapping, graph, or a table, it is not a function. No repeated x's. Y can repeat, x cannot repeat. Under functions, there's two types. There's discrete and continuous. Discrete is when in graph, the points of a function are connected because the values are distinct and separated. So if you look at a graph and you can't see a pattern, and the points are all out of place, then it's a discrete function. Continuous, the word continuous, you continuing with a flow, non-stop. When it's on graph, the points are connected, forming a line or a smooth curve because the values of the set can take on any value within the interval. So it just keeps on going, there's no break. So continuous, you hear the word continuous, you know that graph is going on, doing its thing, and not being interrupted by any outside force. Right, so we have an example, and this is dealing with ice sculpting. So there's a competition, and the sculpture's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. So they took measurements of 5 teams. They have the different height ranges. And the first thing was to make a table showing the values, showing the relation between the ice sculpting team and the height of their sculpture. So the first one got a table. You got each team. You label it, you got your X's, you got your Y, you label the team numbers, and then their height for their sculpture. All right, start through back. Make sure that each X matches up with its Y. Second thing was determine the domain and the range of the function. If you remember back to what the domain is and the range is, you know, domain deals with the X values, and the range deals with the Y values. So domain was the team number 1 through 5, and the height range, the range is the height from 3.2 to 5.1. The next one is write the data as a set of ordered pairs and then graph the data. So already have it graphed, and then you write it as an ordered pair. So you got your parentheses, X and Y, and then you plot it. So looking at this graph, it looks, if you were to trace it, it looks like it's on this, it dips down and then goes that way. So it says, why do we not connect the dots? So in this situation, why are we not connecting the dots? Because basically, we're plotting the points for each team, and they have their own height for their sculpture. So in this case, we wouldn't connect these dots because there's no constant. The points don't rely on each other. It's separate teams. They have their own individual height. Their team 1's height has nothing to do with team 2, 3, and 4, 5 height. So there's no connection. They don't rely on each other. That's why it's not connected. And then what kind of function is this? We had 2 functions that we learned just a few minutes ago. We have continuous and discrete. If you look at it, you notice how, like I said, connect. Whoop. So this would be a discrete function. Discrete function, it's all wonky, it's not a continuous flow, there's a break, and plus, based on this question, the last question, there's no constant. The points don't rely on each other. There's no relation between those two, so it's not going to give you that continuous flow. There's no connection. All right. So how to determine if a graph is a function? There's something called the vertical line test. If no vertical line can be drawn so that it intersects the graph more, it intersects the graph more than once, then the graph is a function. So if you look at these examples, this is a function, because if you were to draw a vertical line, like single vertical line, that line that you drew will only hit that graph once. It hits that curve once. Whereas this is not a function, because notice how you draw that line and it hits it here and here. So if you hit a graph more than once, then it's not a function. This is a function. You have this vertical line. If you had a vertical line, we use the y-axis in this case, passing through the point, it hits it only once. And they're like, how do you know? I mean, you might think this is not a function because it hits this point and this point. But look at this. Look at the circle. This is not shaded, this is shaded. If these were both shaded, then this wouldn't be a function. If at least one of them is shaded, they're on the same vertical line, only one is shaded, then it is a function. But if these were both not shaded, then it's not a function. I mean, if they were both shaded, then it's not a function. If they were both not shaded, this would not be a function because there's a break. That means when you get to the 0 line, there's no point on that line. So basically the graph, this line stops at -1, anything before 0, and then continued after 0. So 0 somehow disappeared. There's a break there. But in this case, there's one shaded, one not shaded, it's a function. All right, let's go on to the next one. So how do you determine if an equation is a function? So they'll give you an equation, and most of you, majority of you, are used to seeing y equals whatever the expression is after the equal sign. So in order to, if this makes it easier for you to understand and visualize it, see it better, turn it into the y equals, and then the expression. So you have y equals 3x plus 8. Basically, you added 3x on both sides, so y can be by itself, and then you got your equation y equals 3x plus 8. Once you do that, you have to make a table of values. So using this equation, you're going to plug in your x. Choose your x value. So in this case, I chose -1, 0, and 1. I can move that. It's up there. So this is 1, -1, 0, 1. And then I plugged it into the equation to find my y value. So by doing that, I plugged it in, had my x equals whatever number I chose, plugged it in, and I found my y value. And then once I did that, I put it into the table. So once I have my table, then I can start plotting the points, which I will do using purple. The first one is -1, 5. The -1, 5. That's 0, 8, 0, 8. And then we have 1, 11. Well, that would be over here. So I'm just going to guess it. And now I'm going to connect it. In this case, you can connect it because they are related. There is some kind of connection between them. I'll use this one. So when you connect it, I have my line. My line would continuously go this way. If you were to plot more points, but you know that would be a straight line, then make sure you have your arrows. Your arrows going in both directions because that line is continuous. It's not going to stop. And of course, you need your label. And when you label your lines, go with the original. So the original one was -3x plus y equals 8. So now we graphed it, we tabled it, we did what we had to do. And the question is there one distinct output for each input? Well, let's look at it. Let's take a line. Let's take a red line, and I'm going to just, that's a bit thick. Let me try that again. I want something smaller than that. All right, let's undo that. And I'll do something that is not so big like that. Line. I use that. Okay. So I drew a line. It hits that graph once. So if I did it another time, it would do that. It would do the same thing. So yes, there is. So does it pass the vertical line test? Yes, we just did it. So this would be a function. And when you have this written like this, y equals whatever number x plus whatever number, it is a function. As long as there's no powers or some other things going on, it's just simple like this, then it's a function. All right, let's move on. Next example, how about this? If you were to solve for this, you only know that you would get 2, and your answer, of course, would be 8. So this would be the only ordered pair that fits this equation. So if you were to plot this point, so you got 2, I didn't label it, but you can count the boxes. 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. That's your point. And then they want to know what kind of line is this. So since your answer, I should write it over here, your x would equal 2. So when you have x equals 2, it's going to be a vertical line. And I'm going to draw that. Put it here and then label that, of course. Always label. So this one is x equals 2. And they want to know what kind of line it is. As you can see, we know it's a vertical line. And is it a function? No. Vertical lines can't be functions. So anytime you see a vertical line, not a function. Let's see if there's anything else. No. Let's move on. All right, so the summary. Functions can be represented in the following ways. You have a table, mapping, equation, but this is not a function because you have that power there. But if it was just half x minus 1, yes, it'd be a function. You see that f of x. And you have a graph. So there's 4 ways that a function can be represented.
All right, so I'm going to stop here. This will be functions lesson 4A, and then it will pick up for lesson 4B.